Yeah, we are in the 4th week of our Push N900 project, and as we say in German, Bergfest, mountain festival. So it's the peak. Yeah, we reached the peak, and now, yeah, another problem we are facing is.
Yeah, the weather. If we look outside, it's really snowy and there's ice all over the place.
Yeah. I don't know. Yeah, they talk every time about this climate exchange, but now climate change, and now it's so cold, and we can't test our skateboard. Yeah, because all this dirt and snow and
no skating weather.
We have just three weeks with this week, and then we must present our work, right?
Yeah, we go to London and present our work.
Yeah, we will meet all the other teams. Yeah, and this gives us a motivation to do the last work. We put all our free time in this project, and more than the free time too.
So last time we showed how we designed the board, and it looks like this. And we started assembling them and failed, and then we continued and we got it working, and it looks like this in the finished state with various hardware debug elements such as wires, and it basically works.
So we have this spacer here, and as we can see, the board fits right in. So that's what it's supposed to look like, and yeah, it's very satisfying. Okay, and the truck fits right in here. The shape is the same. Generally, we want to know if there's actually a skater on the board, and therefore we got two pressure sensors in here, under the grip tape, in here, at one side and on the other side. And the wires go through the board to here.
And here we got the connection for the battery power and the programmers, so we can debug and run the code without unscrewing everything. First we connect the power, the board is powering up, then we connect the programmer cable to an SDK 500 programmer board for the Mega chip. Turn it on. We can see that the board is correctly recognized and prints out the fuses.
Now we'll try if we can discover the Bluetooth module. This is the hardware address of the module. And now we'll try to connect the phone to the Bluetooth module. Okay, it's connected. And so now we see we get no output from the Bluetooth module, so no data, and yeah, we have to find out why.
Okay, so last time we had this QV box layout, so it's vertical and we have all these buttons like this. But now I use another layout and put it inside. So I have here this H box 1, so it's a horizontal box layout, and I can put the buttons inside like this, so we have the back button here.
So this method is for the play screen. Yeah, but we need to move it to an own class later, right?
Yeah,
yes.
We started with Flo's design, and we started to put the designs in the background and to have real buttons and really some GUI functionality.
Okay, it works. So settings, I click on settings.
Open settings window, so we don't have this yet. Do you want to try it?
Yeah, okay, so this is a mock-up from Flo. Yeah, I really like this guys. Yeah, Flo did awesome work
They're
here.
cute.
Multiplayer.
So you can't click on these icons yet because I thought you won't click on the whole icon, but we can change this, of course. So click on multiplayer. On the text.
I would prefer, because with your finger, when you are on the board, I think it's better. Okay, single player. Okay. This is too small. The font is too small. What do you think?
Yeah, and there's so much space left. I think this is no problem to make it bigger. And
yeah. Settings.
Oh, settings window.
Okay, play. Come on. Yeah, the buttons are too small. Not my fingers. Yeah. So start multiplayer game, single player. So start challenge, high score.
View high score.
Okay, and now I go back.
Going back, not implemented yet.
Until now we made mockups, but now we need the real graphics, the real items for the graphic user interface.
What we were thinking was the data which comes in from the skateboard sensors. It kind of looks like this, and then the trick happens. So maybe there's an ollie, the skateboard starts to lift off. So maybe it goes on like this, he's driving, and then he does another ollie. So 2 kick flips here. There are 2 things we need to know. The first thing is the time at which the trick starts, which would be here. And here, for the kick flip, it would be here and here. And the second step is to look at this profile here. So maybe this is how an ollie looks like. Now this profile is like a kickflip looks like. They also look different a little bit for the same trick, because you never do the same trick exactly in the same way. But on average, they look quite similar. An ollie normally looks somehow like this. And later, then the skater is not in training mode anymore, but is really skating and playing the game. We can use the first part of the algorithm to detect the moment the skateboard is lifting the ground or the kick starts. And we could use all these patterns, which we learned before, and match them on these ones. The real skater drives on the real skateboard and is playing the game. And now the application will not know which trick he's doing, but the application needs to detect this. This might be an ollie. Here, doesn't look like this, doesn't look like this. So maybe he will just say, okay, something happened, but I don't know what. And finally this could be kickflip. This is the way we think the algorithm might work in the end.
These 2 windows show 2 different tricks. This one is the faked impossible, and this one is a simple ollie. Okay, see, we start rolling.
Okay, this is
Didn't detect it.
Maybe it was the ollie after all.
Okay, you see the rolling start. And hopefully now the first failed trick.
Oh, but yeah, okay. I think he didn't detect the start of the trick.
Yeah, otherwise you should draw a red line.
No.
There it is. Okay, so seems to work with segmentation.
Well, we still have to detect which trick it was, but the start of the trick was correctly.
Probably the amplitude was not high enough.
Pretty ollie-like to me.
I guess I just didn't kick hard enough.
Nah, I guess like really high ollies will be no problem to detect.
Okay, this one.
Yeah.
Badly, but
It worked.
and I think once you get the right classification points, it shouldn't be too hard to detect which trick it is. Okay, this is our classification method. Here you can see the starting points of the tricks, which we detected. And from these points we used a 1 second time window, which we passed to our classifier. And here you can see the result with a correct rate of 92%, which is almost perfect. I think this is quite promising for the first start.